Hi. In this video, we're going to work on the central limit theorem lab. So coming on, I'm going to share my screen. We're open up into our course and choose the data analysis assignments content area. And then we're going to look here at this .docx document. So let's open that up. Okay, so I'm going to go ahead and work on here. I'll need to enable editing. So we're going to click on this. This is a link here. So click and it will bring us over to the sampling distribution. This is a bunch of little applets. And so the first thing that we're going to do, look at the question. It says the normal distribution on the app has a mean mu equals 16 and the standard deviation sigma equals 5. Take samples of size 5 and determine the distribution of the sample mean by running the simulation 10,000 times. Okay, so over here, we're going to begin. So click on begin to start. And then what we have, the top, there are some axes here. The top one represents the parent population. It's from this population that we're going to take a sample. So for example, we can click animate. And what we saw was 5 different values being sampled from the parent population. And then down here, the sample mean is taken. I can animate again. Notice this time we didn't get exactly the same value for X bar, the sample mean, but we got another one and was over here. And now we have another one. So we have each time we likely could get a different value of the sample mean. So this here, parent population, this is the mean of 16 and the standard deviation of 5. And we are taking samples of size 5. Let's go ahead and take a sample of size 10,000. And now we have 10,000 means that are represented here in the smaller curve, the third curve down. This is the distribution of the sample mean. It has a mean. In it came out to 16.04. That is the mean of this little blue distribution, the distribution of the sample mean. And the standard deviation is 2.23. Okay, so parent population, one thing we're going to notice is that the mean of the parent population was 16 and the mean of the distribution of the sample means was just about the same, 16.04. So it turns out that as you take samples from a parent population, the distribution of the sample mean has the same center as the parent, but it becomes less variable, right? So it's less spread. So over here, we have a standard deviation in the parent distribution of 5, but in the distribution of the sample mean, the standard deviation is 2.23. Okay, so let's look at the problems and we'll answer the questions. So the first problem says, the blue distribution on the third axis is the distribution of X bar. What is the mean of the distribution? So I'm going to put 16.04 because that's the mean of my distribution. We can come right in here and type 6. You might have a different one. Yours might be 16 or 15 point something, right? And the sample standard deviation, 2.23. Okay. So the number 1 is doing the problem with the simulator, and number 2 with the simulation is to do the problem using the formulas. So we have some formulas on the formula card. Let's go ahead and look at the formula card. Hopefully we can find the formula card here. Okay. All right, the formula card. Okay, so over here is the chapter 7. This is the first page, and the top of the second page is the chapter 7 formulas. Notice what we have. Mu sub x bar, the mean of that small distribution with the blue, that's mu sub x bar, that's the mean of the distribution of x bar, is equal to mu, the mean of the parent, right? So we saw that with the distributions lining on top of each other. And the standard deviation of the variable x bar, sigma sub x bar, is sigma over the square root of n. So what I want to do is I want to go back to the problems that we were working with where mu was 16, sigma was 5, and the sample size was 5. And I want to plug them into these formulas and see if what I get is in agreement with what we got from the simulation. All right, let's go. So in this problem, we're given mu is 16 and sigma is 5. So I'm going to go ahead and borrow that because it has the symbols there. And, you know, maybe that's nice to see it with the symbols. So this is given, that's my given, right? So mu sub x bar equals mu, and that's going to be 16 because it was given in the problem. And sigma sub x bar, right, is going to be sigma, which is 5 over the square root of n. These are our givens here. Let's go ahead and work on that. You can write this by hand. You can hack it in any way you want. It doesn't matter. You don't have to make it look like this, but I'm just kind of copying and pasting and then substituting. And so go ahead and let's express this to 2 decimal places. 5 over the square root of 5. And we did that, we get 2.24. And so does this agree? Do these answers agree with what we got from the simulator? Yes, that's quite a lot of agreement, right? Okay. So now it's your turn. What we're going to do is run the app again. We're going to take another investigation. This time, we're going to set the sample size to 10. So let's look at that. All right, so we'll clear everything. And I'm just going to show you this part, then I want you to finish the rest of the questions on your own, but I want to make sure you can get the simulator to work. Okay, we're going to take samples of size 10. So we're going to change from the third axis down, go ahead and set the n equals 10. Okay, and now you can animate. This time, rather than seeing 5 draws from your parent population, you have 10, and you can do it again. And of course, you can do it 10,000 times. Okay, well, that's where the video stops. So the rest is for you. So please record the answers to problem number 3, and then use the formulas again the second time, replacing the n with 10, the sample size. All right, let me know if you have any questions. Take care.